have graded it. And if you go back and you look at that assignment, you will see the correct answers. So if you haven't already gone back and looked at that, like I would suggest you do that after you've gone over this and watched it to figure out what you got wrong and why you got it wrong. Okay, so the first thing that you need to do, I already wrote some notes on here. We're looking in this worksheet, not the one that y'all did on Tuesday, but the one that you guys did on Monday. You're looking at distance on the y-axis and time on the x-axis. And so the first thing, before you even look at any of this over here, you need to look at the graph and figure out what's happening. And so I went ahead and wrote some notes on this first page. If we look at where both of the lines went up on the distance, they both went 10 miles, right? If I look at A, and I draw a line down, say that's 4 minutes. B, it took them 10 minutes to do that. So just by looking at that and analyzing what we see there, we can tell that it took B a whole lot longer to get 10 miles than it took A to get 10 miles, right? So we can come over here and look at our options. Object B is traveling at a greater rate of speed than object A. Nope, wrong. I already marked that out. B, object A is traveling at a greater rate of speed than object B. Well, it did seem like A had to move faster, right? And if we look at that line, it's more, its slope is less than the other one. So that seems to make sense. Object B is speeding up and object A is speeding up. Well, those are not correct because if we look over here, a sloping straight line means a constant speed. Both of these are sloping and they're straight, so it's constant. So that leaves us with B, right? Number 2. So here we just have one straight line across. And so say this is at 5 meters. Well, it's at 5 meters here. And say, 10 seconds have gone by. So 10 seconds here, it's still at 5 meters. So it seems as if this thing, if it started at 5 meters at 0 seconds, and at 10 seconds it was still at 5 meters, then it's not moving, right? So the object is traveling at a constant speed? No, because it's not moving. The object is speeding up? No, it's not moving. The object is slowing down? No, it didn't even start, right? So D, the object is at rest. Perfect. All right, so 3. Here, and let's look over here at my little notes. Downward curve is going to be, looks like that one, right? And a downward curve means slowing down. So anytime you see a curve going like that, it means it's slowing down. All right, so the object, not a constant speed, because we know this up here is a constant speed. So wrong. Object is speeding up. Nope, because it is not the upward curve. And the object is slowing down. I'm going to go ahead and circle it, but let's check this. The object is at rest. Nope, because that's at rest. So wrong. Okay, and this one, now we've kind of gone over everything. We know straight horizontal lines, no, straight sloping lines that are like this one, that means constant, right? So straight, that portion from there to there is constant. But then we know straight horizontal lines, that's at rest. Constant, constant, constant. So, A, object C traveled further than object B. Well, C's here, I kind of covered it up. But if we look at the distance, because it said further, we can kind of draw a line right here and see my line squarely. but we can see that they all traveled the same distance, so not true. Object B traveled at a lower average speed than object C. B's here, C's there. If it was going at a lower speed, then it would have been way out here because it would have taken it more time to get the same distance, right? So that's wrong. Object C traveled at the greatest average speed. So C's traveling the fastest. Well, why did it take C the longest time to get to the 10 miles or whatever it was? No. So object A traveled at a constant speed. We know that straight lines are constant. Boom. That checks out. Perfect. Okay, so now moving on. Here, before we even look at that, we're going to do the same thing. And I want to move that little guy. Oh, goodness. Okay, I'm going to move him over there. Okay, so same thing. We want to look over here at this, figure out what this is saying to us before we look at this. So we can see that our object, whatever it was, say it started at 8 meters. Okay, and it started up here at 8 meters. Well, it started at 0 seconds. But as the seconds went by, the meters went down. So by the time it gets over here, it's at 0 meters and maybe, let's say, 8 seconds, right? So let's read our thing. The object is speeding up, or B, the object's distance from a reference point is decreasing over time. The object's distance from a reference point is increasing over time, or the object is slowing down. So whenever it says reference point, every time you're looking at a distance and time graph, our reference point is right here. Like, so say this is my house. I started out 4 blocks from my house, and it took me 8 seconds to get back to where my house was, right? Because that goes back to the reference point. So, was the object's distance from the reference point decreasing or increasing? Well, if we're way up here, we're 8 meters away. We're 8 meters away from the reference point, and we slowly got closer, so it's decreasing. Number 6. So 6, now we have this different curve, an upward curve. That means it's going to be speeding up, right? Our other curve went boom, like that. This curve goes boom, up. So we know speeding up. So boom, object is speeding up. Number 7. Now let's look at this. We have straight horizontal lines. What do straight horizontal lines mean? No motion. All right, so say this one's at, say 50 meters, and this one's at 25 meters. Because this is our distance on the y-axis. So we know that these aren't the same meters because they're at different parts. So these are at different positions or different locations. As time's going by, they're still at the same location. So these objects are traveling at a constant speed? No, they're not even moving. These objects have stopped in the same location? Same? Really? No, because this one's at 25 meters and that one's at 50 meters. C, one of these objects is traveling faster than the other. Are they traveling? Are they moving? Do they have a speed? No, they do not. Not true. These objects are at rest in different positions. Okay, we know that they're at rest. They're not in motion. That checks out. Are they in different positions? Yeah, this one's at 25 meters and that one's at 50. Boom. That's our answer. Number 8. Okay, so before we look at those, look over here. We can see that they both ended up at the same time and the same distance, right? But where is it different? This one started here and that one started there. This is time. So say this was 1 second. This was 3 seconds. So they traveled the same distance. They ended at the same time, but did they travel the same time? If this one started after 1 second, because we know that's 0 seconds, right? Minus is bad, sorry. That's still bad. But 0 is right there. All right, so if we say they made it, this is 10 seconds. So 10 minus 1, this guy, he traveled 9 seconds. This guy, 10 minus 3, 7 seconds. All right, so they traveled the same distance, but they ended at the same time, but they didn't travel the same amount of time, right? So A, these objects started from different positions. False, because if they started from different positions, they would be different up here. Wrong. These objects travel the same amount of time. They stopped at the same time, indeed, but they did not travel at the same time. C, these objects traveled the same distance. That seems to be legit. These objects traveled at the same speed. How would you have one starting at 1 second, one starting at 3 seconds, both of them end up at the same distance at the same time? Not true. So, boom. They traveled the same distance because we can see this spot. Boom. Put it right over there. All right, now number 9. Okay, so again, before you look at that, look over here. We have 2 lines, right? We have one that started right there, 0, 0. We have another one that started up here. So maybe this one's 0 miles and this one's 2 miles, right? So they started at different distances. They're both straight lines, so that means they're constant. Y'all know I can't spell. I had to think for a second. Okay, so they're both constant. You know, they're parallel. It seems like they're probably going the same speed. They just started at different points, right? They started at the same time because they both started there where time is 0. But this one started at mile 0. That one started at mile 20. So, A, these 2 objects were traveling at the same speed but began moving at different times. Did they move at different times? No, they both started at 0. B, these 2 objects were traveling at the same speed. Well, we did say that, but began in different positions. 0 miles, 2 miles. Boom. For time, we're going to go ahead and move on. Number 10. Okay, we have another one of our curves here. Our curve is going down. And look, whenever you look at this curve, so it's going down, so we know it's slowing down, right? That shape in that curve means that it's slowing down. But look at what it does. If I draw a line ever so perfectly, it goes straight there. And what does a straight line mean? That means it's at rest, right? So this part is slowing. And then it goes, it stops. So this object slowed down gradually, came to a stop. Boom. That's our answer. You should always read through the other ones but for time's sakes, because I don't want this to be forever, that's the answer. Number 11. Okay, same thing that we've done on all the others. We look at it. They stopped at the same time. They traveled the same distance, but they started at different distances. Maybe this is 0 kilometers. This one's 4 kilometers. Okay, so travel the same distance, stopped at the same time, started in different spots. So these objects traveled the same distance. Well, let's look. They stopped at the same distance. I may have confused y'all there. But this one, it started at 0 and say this is 10 kilometers, right? So 0 or 10 minus 0, this guy went 10 kilometers. This one, he started at 4. That would be me. So 10 minus 4 would be 6 kilometers. Like, I get the head start because I'm in the wheelchair, right? So did they go the same distance? No, they didn't. These objects traveled for the same amount of time. They both started right here on that 0, right? So that seems correct. And, yeah, no. Okay, so this one. We started at 0 miles. We went up to, say, 10 miles. And say this is 0 minutes. I'm trying to use different units here. So 0 minutes, and we'll say this is 5 minutes. So we can see it started at 0 miles. It went up 10 miles and then came back down to 0 miles where it started. All right, so it started and stopped in the same location. So which one of these things say this? It rolled back to its starting position. All right, so hopefully this is all starting to kind of make sense to you guys. Now, what y'all are going to do after you watch that, you're going to have this little assignment. So we should be able to look at graphs and understand what's going on in them. Okay, and with scenarios, you should be able to read a scenario and place what is happening when. So this one says, an airplane is descending to land at the airport. During its descent, it had to fly in circles until the landing was cleared for other planes. Explain what's occurring during each of the segments. So segments, it's saying like, boom, this is something that's the same, A to B. So I went ahead and wrote that out there. So from A to B, what is happening? It's flying up in the air, right? And it's starting to descend. So starts to, how do I even spell descend? Sorry, I know I can't spell. So it starts to descend. Well then, B to C, it flatlines. What does that mean with distance to time graphs? No motion. So that would be where it circles. Okay, so it's circling around like all this time. It's circling around waiting for those other planes to get out of the way. Then from C to D here, what is it going to do? It goes in to land. It descends all the way back down to our 0 miles or ground level, right? So what you guys are going to do, y'all are going to do question 2 on your own. You'll read that, and you really need to look up here and figure out what it's saying. And then you have these questions, and this one is just like the one we just did. They already give you the segments here, so you're going to read this scenario up here, explain what's happening. A to B, that's what you'll write there. B to C, you'll write there. C to D goes there. D to F goes there. Okay? And so you're going to do those. And then this one, I most definitely am having y'all do this one. And we'll kind of see. I don't want this to take all class period. So if you guys get done with that one and you want extra credit, because if when y'all do this and you do the other parts, then that will correct the grades that y'all made on this sheet if you did not pass it. If you do this, I will give you guys extra credit. So you're going to write out, make up a good narrative, a good one, okay? And you're going to explain what this is. So you're going to come up with a storyline. So yeah, hopefully this helps you, a little bit more practice. After y'all are done with this, I want you to work on as much as the review, the mini assessment review that y'all can do. And on Thursday, I'll have another video explaining the speed and time graphs and another little scenario and thing like this for y'all to fix that grade if you need to. And then we'll finish the review. I need that review in like by 4 o'clock on Thursday, so that way I can grade it. Those people that are in school, y'all are going to grade it in class, so it needs to be done. That way you can take it home and you can study and you can be prepared for the mini assessment. All right, so please let me know if I can help you all. And I really, totally hope this helped. Write that down right there if you need some notes while you're doing your stuff. All right? Hope so, guys.